Okay. All right. So we're going to go over to, we said number 13, right? 13 and 16.
Yep.
Okay. So starting with 13. Domain and range problem. Okay. I feel like these are kind of hard to, well, maybe it won't be too hard to see on the screen. So we'll try it on the screen. And if I have to, I can draw it on paper to see it worked out. But this, I would say, if we need to look at the domain, can you guys tell me what the domain is by definition, or how do you guys think about the domain? Because,
The X.
yeah, so if this was like a set of ordered pairs, we would think about it as all of the X's. But when we're talking about a graph, I like to think about this as how wide is the graph. But we're going to be using the x-axis kind of like a ruler or like a measuring tape to measure how far to the left do we go, how far to the right does the graph go. Okay. So if I think about this graph, it has its vertex here at -1, comma 4, and that's kind of like the middle of the graph, right? How far to the left does the graph go? Well, sometimes students get caught up and they go all the way to the left and maybe they stop at the x-intercept, but that's not what we're looking at. Okay. We're asking ourselves, if we were to walk this way, does the graph continue getting wider or does it have a stopping place? So if you kind of trace the graph, you notice that it's getting wider and wider. I'm kind of exaggerating it right now, but as it goes down, it's also pushing further and further out. Are you guys okay with that? Or is that a little bit confusing?
So I guess it just depends on where the graph is at.
Um, Not really. I mean, it doesn't matter the location. Like it's just so happens that this graph continues going down, but it's also moving to the left, right? Because if you
Because
think
you
about
can,
something that goes straight down doesn't have any leftward motion, but if it's going kind of diagonal, it's going both down and left at the same time.
I was thinking, what I think, what was that term? It was like the line of symmetry or something like that.
Yeah,
Like
there's
you go at the very top and then you use it to guide it. And if it's going like left instead of like right or center, then you can just assume it's going left.
Yeah, exactly. So, that's one way maybe you could think about it. Like if this is the axis of symmetry right in the middle of the graph, then this graph is kind of going out to the left, right, as it goes
Okay.
down. And so if it's going to keep on pushing left, we're going to say that, well, the graph is going to push left towards negative infinity. So that's the left boundary of this graph. Okay. And then the right boundary is also thinking about like, okay, on the right side of this graph, is it pushing out to the right? And sure enough, as you move down, it's going down and out, right? Kind of looking like a Christmas tree as I do this. I'm exaggerating how far out it's pushing because it's kind of pushing gradually out to the right. But if you were to continue this, eventually it would get wider and wider as we go down in both directions. So if we're pushing out to the right in this direction, we're walking towards positive infinity. So the domain tracking from left to right, it goes from negative infinity to positive infinity. Does that make a little bit more sense?
Yeah.
Now
Well, I mean,
there are some graphs where it's a little bit more obvious than this, but I interrupted somebody who was going to ask a question. So what's up? What's your question?
I was just going to say like the for the domain, it's kind of like easy to see because they're both going infinity. So you can just write it as like negative infinity and then infinity.
Yeah, and another thing that's helpful is that all quadratic functions have the same domain. I don't know if anybody has noticed that, but they all have the domain negative infinity to positive infinity.
It's just I got the domain down. It's just trying to find the range. It's more frustrating.
Okay, so let's do that. If does anybody have any other questions about the domain before we start with the range? Okay. So I like to think of the range as being the lowest y value all the way to the highest y value. So sometimes I say um, the bottom of the graph, how far down does it go? Not bottom. I had a moment of dyslexia there. And then the top of the graph, right? So if you think about like imagine that like I'm a person, which should be easy to do because I am a person. Um, and I said, okay, I want to get like a measuring tape and measure how tall the graph is. And so like I'm kind of like holding my measuring tape up until I get to the height, right? I mark the high point of the graph. What is the highest y value that I would measure?
Or
Four.
Yeah, 4. So you don't have to do this in any particular order when you're working it out, but the top of this graph stops at 4 because if I were to measure this, this just goes to 4 right here, right? And that's the top. Are you guys okay with that?
Yes.
And then I'll flip my measuring tape around and say like, well, how far down does this go?
Infinity.
Yeah, because these arrows imply that it's going to keep on going down forever. So if I can't, I'm going to keep on pulling tape and pulling tape and pulling tape, but it's never going to stop there. So I'm going to say this goes down not to infinity because infinity implies positive, but we want to be specific that the bottom is negative infinity there. Are you guys okay with that?
Yes.
Yes.
yeah.
Okay.
Also, Mr. Aguilar.
Yeah.
So I noticed on this part,
Hmm.
um, I think it's for this example, would
Yeah.
it be like the parentheses on the left and then brackets to the right?
Yeah. So negative
Yeah.
infinity and positive infinity always has a parentheses.
Okay.
But because we have a definite stopping point at the top of the graph, we have
Right.
to indicate that with a bracket.
I got him confused last time, so I was worried about accidentally making the same mistake.
Yeah, the only time, and you guys aren't going to see this, just to give you a heads up, the only time that you would have a parentheses on the top of a graph that looks like this is if you had an open point, an open circle on the very top point. If
Mm.
that were the case, then this would be a parentheses. But these parabolas are very simple. So there's either going to be a definite top or a definite bottom, but there's not going to be an ambiguous case there. Okay. Any other questions about domain and range? Are you guys okay with these answers that we're about to type in? Okay. So then that should be negative infinity to positive infinity. Okay. I hate typing these in as much as you guys, so we're here in solidarity. And then let's go parentheses bracket. That's going to be negative infinity, which is the bottom. And then the top, which was 4. And then we can check this and we should be good. Okay. So next one in the chat was number 16. So let's take a look at that one. Find the vertex. Okay. I'm going to write this one down on paper. So just give me a moment. But while you're giving me that moment, can you tell me whether or not this equation, whether this function is in vertex form or standard form? Or if you have no clue whether it's in standard form or vertex form. Any ideas?
I'll say standard form.
Okay. Now, are we just taking a shot in the dark there, or what was your thinking, your thought process there?
Because it has three terms, and I'm looking at it in that way. And the vortexes usually have parentheses.
Yeah, that's exactly right. Right. That's a really killer indication. So remember, standard form should be recognizable at this point because I've kind of been training you guys to identify standard form as ax squared plus bx plus c. That's going to be the standard form of a quadratic equation. And that is going to be in contrast versus your vertex form, which will look more like f of x is equal to a times x minus h squared plus k, right? Where this is our vertex form. Now, this problem is asking us to find the vertex, and if it was in vertex form, well, we could just take the opposite of negative h and then take the k, and then we'd be done, right? But we don't have this in vertex form, right? So in standard form, we have a formula to find the vertex, and the vertex is h comma k, where h can be found by taking negative b over 2a. Do you guys remember that formula?
Mhm.
So like if you need and this is a prime example with like the kind of information that you might put on your note sheet, right? Because it cannot be the case that like when you see a problem, you're just like, I have no idea what to do. You should be able to look at the equation and like ask yourself some very simple questions like, what form is this in? Or like when it came to the factoring, I had you guys do like, how many terms are there, right? If there's 3 terms, you do this. If there's 4 terms, you do this other thing. So now when we're talking about quadratic functions, we have to ask ourselves, is it standard form? Is it vertex form? If it's standard form, we'll go ahead and pull up this formula, and then we can just say, okay, this is going to be negative b. What is the value of b?
24,
Not 24,
negative 24.
right? And those details matter, right? I'm not just trying to be like a pain in the butt. It is going to matter, right? When you type this into the calculator or when you write it down, you need that negative 24. There's a negative in the formula, and there's a negative for this value of b. Then
Yeah,
what's
that's
the
why I miss points is those signs, the negative signs. That's how I miss points on tests and homework.
Yeah, and you got to be very careful there because sometimes we tell ourselves like, "Oh, I already have a negative sign. I don't need the extra one." But no, you have to plug in that value of b. If b is negative, then you're going to bring that negative sign with it. Okay? Kind of like you're you have a daughter or son and they have a boyfriend or a partner that you just hate. Well, guess what? They're bringing that partner with them regardless of whether you like them or not. So just bring it down, okay? Um, so 2a, what is the value of a?
2.
Yeah, 2. Okay. So this is one of those things where I said like you already grabbed the formula, you already plugged the things in correctly, we remembered our negative sign. Do not stress yourself out by trying to do this by hand. Just type it into the calculator exactly the way it looks. So I'm going to put a fraction, which is alpha, y equals. Hopefully we've memorized how to get those fancy fractions. And I'm going to zoom in just so you can see what I'm putting in there. I'm going to put negative parentheses negative 24, close the parentheses. And then I'm going to put 2 parentheses 2, exactly what I wrote down. Hit enter, and I get 6. Okay, so that's one part of my vertex. That's the h part. Any questions about finding the h part?
I have a question.
Yeah, go ahead.
How did you get the 2 in the parentheses? Is that because it's the 2x squared?
Yes. So remember, when you have something in standard form, we like to label this as a is equal to 2, b is equal to negative 24, and c is equal to negative 45. So for this formula, b was the negative 24. Are you okay with that?
Yes.
And then the a comes from the coefficient
Two.
here in front of the x squared.
Oh, okay.
Yeah.
Got it.
And that's why it's like really important to memorize the process and like why we're using these placeholders A, B, and C. Because like sometimes the student might confuse themselves and they say like, oh, I guess we just put a 2 and a 2 here because we had a 2 outside the parentheses, so we just put that same thing inside the parentheses. And like you're just making stuff up there, right? And you want to make sure that you know where we're grabbing this 2 from and that this 2 is just from the formula. Okay. So just be very careful and be kind of mindful of that. Can you guys tell me what I'm going to do with this 6 now?
Take that 6 and plug it into the H.
So the 6 is H.
I mean the into the other formula, the f of x,
Yeah,
because
that's
you're trying
exactly
to
right.
get the vortex.
Yeah, so I'm trying to get the vertex, and now once I have this 6, I need to plug it back into the original function, right? So that's going to be f of 6. And what was the original equation or original function that they gave us?
2x squared.
Yeah, Corey, you got it. This is the thing we're plugging it back into, right? So we're just going to put 2 times x squared. I'm just putting parentheses though because we're about to plug in what?
6.
We're about to plug in a 6. So I'm going to put just parentheses for now. Minus 24 parentheses minus 45. I'm kind of squeezing it in there. And then I can take this 6, which was the h that I got, and I'll plug it into the equation. And now I can just put this in the calculator. Again, as long as you can memorize that process, I don't care whether you can do PEMDAS by hand or in your head. I would just say, okay, let's just do this in the calculator so that we don't make any mistakes. Type this exactly the way we see it. 2 parentheses 6 squared minus 24 parentheses 6 close parentheses minus 45. And notice like, I'm not doing this necessarily for y'all's benefit, but like I'm touching each part so that I don't get confused and get lost because I know that sometimes you guys look down at some numbers and then you glance somewhere else on the page and then you accidentally, your brain kind of like copies a different number and then puts it into the formula or types something wrong into the calculator. So like to keep myself steady and keep myself on track, I'm touching the things that I'm typing in as I go through, also to make sure that I typed everything in. Once I've typed everything in, it looks exactly like what I wrote down. I can then hit enter and I get negative 117. So at that point, you're going to have to say to yourself, it doesn't matter that I think negative 117 is a weird number because you guys might say like, oh, that's kind of big, or that negative number is like, can that possibly be right? But like, why are you second guessing yourself? Right? We don't need any of that. If you typed it, if you're doing the process correctly and you typed it in correct, then like you should be able to trust the calculator. I don't know who hurt you in the past, but like you got to get over that trauma a little bit, right? So this value here is K. Okay, so now we have our vertex. It should be 6 comma negative 117. And if if we're trusting the process, if we're getting the correct answers in the homework, there's no reason to think like this time when I plug it into the test or into the review that like it's just gonna magically be mad at me. The only reason that Alex is gonna be quote unquote mad at you is if you did something wrong. Okay. It's not like technology changes its mind. It doesn't have mood swings like we do. Okay. Well, very rarely do these technologies have glitches. I've been teaching this for 8 years, and I would say there's less than a 1% glitch rate. So let's type in our answer. We said that this was 6 comma negative 117, and then I'm gonna hit check and pray to God that it's a green check mark. And sure enough, it was because I trusted the process. I don't care that negative 117 looks weird. Who are we to say that that number looks weird?
That would have got me.
So I just want you to know, like, sometimes those answers don't look pretty, right? And maybe we have this bias that we want our numbers to be small and we want them to be whole numbers and we want them to be positive. But like, you have to love all of your children regardless of how ugly they are. Okay, and the 117 is just one of our ugly children, but we still love it. Okay. All right. So, any questions about that one? Did that make sense, Ian? Because you're the one that requested that one. Are you okay with that?
I was thinking, can we do another, I guess, like version of it? Because I know there's two questions in the review that have that format.
Yeah, we could do the try another button here, see get a similar one. Do you want to do another one that's in standard form?
Yeah.
Okay, sure. We'll try another one. I'll do this one just on the screen because I think switching back and forth kind of takes some time. So this is in standard form, right? Are we all good with that? So h is equal to, can you guys tell me what the formula is for h?
B over 2A.
Almost. We're forgetting something.
H
The
equals.
negative B.
It's a negative b.
Oh, no.
Yeah, and that's one thing that you might run into problems with if you're using line paper like me. Sometimes we draw a negative sign on the line, and then when we glance back at it, it just kind of blends in with the line. So like if that happens, maybe just use unlined like plain white paper. Okay. So negative parentheses, and then we have over 2 times parentheses. So what's the value of b in this problem?
-8.
Yeah, so I'm going to put a -8 here. And then what's the value of a?
4.
Yeah, 4. So I'll go ahead and do this in the calculator, okay? Because I don't want to trip myself up by not doing that in the calculator. But can somebody throw this in the calculator and tell me what it is? I already have the answer in my head.
Mm.
It's 1. Our favorite number, maybe. I don't know, right? A small, respectable number, something that we can all agree with, right? Okay, so that's h. Now we're going to take that h, all of you, and eat it. Okay, if you're Catholic, that was a funny joke. If you're not, then maybe you're confused. We're going to plug that into the function, right? So they're calling this function g of x. Doesn't matter what we call it. But now, what am I going to write over here in purple?
X.
Not x. What's the original equation?
4x squared
Yeah, so it's
minus
4.
8x.
So it's 4x squared. So I'm going to put 4 parentheses squared minus, that's a weird minus. Let me back that one up. Minus 8 parentheses minus 115. You guys okay with that? And what are we plugging in for x?
1.
Thank you. Plugging that 1 in. Okay, then we're just going to say to ourselves, let's just put this in the calculator. For the love of God. So that's 4 times 1 squared minus 8 times 1 minus 115. What are you guys getting?
I did it on paper, but I got 107.
We made a mistake, I think. Did anybody get something different? So if you do this on paper, if we were to do this the long way, 1 squared is 1, so that's going to be a 4 minus an 8. Okay, so that takes care of that. And
I
then
got a
Divided too
negative
fast.
119.
minus 115. Wait, can you repeat what you got?
Negative 119.
Negative 119. That's what I got in my calculator. And sure enough, that's what I was on track of to get here because these three things, if you wanted to do them in that step, you can do it. But like I said, I was talking to a student in person earlier today, and like she just kept telling herself, man, I just got to do this in my head. I just got to do this in my head. Like I should know this. And I was telling her, well, yeah, maybe in a perfect world, like everybody would graduate from high school and they would remember this stuff for the rest of their lives, the PEMDAS and stuff like that. But we don't live in a perfect world. So like give yourself some grace, give yourself some kindness, just put it into the calculator. Please trust me. Even I might be young, but I know what I'm talking about. You guys think I want to be teaching this over and over again for 8 years? I don't. I want you guys to pass, but like it's getting crazy. Just listen to me. Please believe me. Okay? Put it in the calculator. It's gonna make it way easier for you. Okay. Um, so we have 1 comma negative 119, and then we say to selves, even though negative 119 is an ugly child, we're gonna love it regardless. And we're going to go ahead and trust it and put it on display for everybody to see. 1 comma negative 119. Then we're going to let go and let God, hit that check button, see if we get a green check mark. Boom. You guys okay with that?
Yeah, that looks good.
Awesome.
Actually, sorry if I'm hogging the class, but
Yeah, a little bit.
I feel a little bad.
That's okay.
Number 17, honestly, I don't even know where to start with that since it's like a word problem.
Number 17. Okay. Um, I will put this one in queue, but I want to give anybody else an opportunity to ask. Were there any other questions that you guys wanted to see worked out? Or are we good to go with 17? Please put your vote in the chat if you're okay with this. Or do you want to vote Ian off the island? Okay. I think I'm going to take the silence as Ian. It's the Ian show. Ian is here to stay. Okay. You thank God I'm not having you guys lip sync for your lives. All right. Let's see. This one I think we want to do on paper, but let's read it first. It says a child kicks a ball into the air, and
Oh
the
goodness.
height of the ball um, can be approximated using this equation here. Y equals negative 16t squared plus 8t plus 9, where t is the number of seconds after the ball was kicked. That was kind of a doozy. This is a two-parter, okay? So I want you to just read one part at a time. This says find the maximum height of the ball, okay? So let me write the equation down because it's always important to write that function down. They said y equals negative 16t squared plus 8t plus 9. Okay, and we're looking for find the maximum height. Okay, so this is where it's going to take some reading comprehension. I feel like it's not a math issue so much as a reading comprehension skill. What does the y represent in this equation? Did it say in the word problem?
The height of the ball.
The height of the ball, right? So the height of the ball is what we're talking about when we write a y down. What does the t represent?
The number of seconds.
The number of seconds after the ball was kicked. That's going to be representing our t here. Okay. So now let me switch over to pencil and paper because I think this will make a lot more sense. What you have to recognize is that they're asking us to find the maximum height of the ball. They said the height is going to be represented by the y in this function, and that t represents the number of seconds after the ball was kicked. Okay. What kind of function are we dealing with in this section? What do we call this kind of a function?
Standard.
Well, it is in standard form, but standard form of what type of equation? Do you guys remember my Spanish lesson here of how to identify what type of equation this is?
Quadratic.
Quadratic, right? We have a squared term, so this is a quadratic. And you have to remember that quadratic functions, what do they look like as far as their graphs are concerned, right? We say that quadratic functions form parabolas, right? These like U-shaped curves. So if you think about this, let me draw a little graph here where the bottom of my graph is time in seconds. And then the y-axis represents the height of the ball. Then as I kick the ball, it should reach a maximum height somewhere, and then eventually gravity is going to bring it back down, and it's going to come back down to the ground, right? And so this is the parabola that we should be expecting, because all quadratics form a parabola. And they're saying we need to find the maximum height. So like there is some point up here that is the highest that the graph will reach. What do we call this point right here at the top of the parabola?
Vertex.
We call that the vertex. And because this vertex happens to be at the top of the function, that vertex is the maximum, right? It's the maximum point. So that's all they're really asking for here. It's saying like use your reading comprehension skills and learn, use everything that you've learned about quadratics and parabolas and these functions so that you can find the maximum height, right? So even though it's a word problem, I would argue that everything that we've seen is a word problem because if you had read the instructions on previous problems, they tell you what to do, right? The students that keep coming to Math World, not necessarily you guys, but some other students, like I routinely hear like, oh, I don't know what it's asking me for. And my first question is always, well, did you read the problem? And they're like, yeah, but I don't know what factor means. And I was like, okay, well, that means that you haven't learned the vocabulary here, right? Maximum here was the key indicator that we needed to find the vertex. So do you guys know how to find the vertex when you have a function in standard form? Like we can call that vertex h comma k, right? How do we find the h?
Negative b over 2 times a.
Yeah, so we're going to go h is equal to negative b over 2 times a. And so we'll do negative parentheses over 2 times something else. Can you guys tell me, based on the function that they gave us, what is the value of b?
8.
It's going to be 8. And what is the value of a?
Negative 16.
Yeah, negative 16. Okay. So we can say h is going to be equal to whatever we get when we throw that in the calculator. And so we should get, what do we get? Negative divided by negative is going to be a positive. 8 divided by 32 is going to be you guys getting 1 over 4.
I got that.
Okay. If you don't like the fraction, and in fact, this problem, when you try to type it in, I don't think it allows you to type a fraction. Remember, this is 1 divided by 4, which is the same thing as 0.25, my bad. 0.25, if you put that as a decimal. So that'd be fine, because this h is really the time here in seconds. So it takes 0.25 seconds to reach its maximum height. But this is asking us to find the maximum height. So if the h here is seconds, then the k has to be over here, the height. So how do we find the k if we already have the h?
Would you plug that in?
Yeah, I'm going to take this 0.25, or you can put it as 1/4. However you prefer, doesn't make a difference. We're going to plug that into the original function. So k is equal to -16 times something squared plus 8 times something plus 9. And we're just plugging in that 0.25 that we found. 0.25, or the 1/4 if you prefer the fractions. I usually would, but I'm trying to go easy on you guys right now. So if we put this into the calculator, and I won't sort of delay, I'll just go ahead and throw it in if you guys are okay with this. -16 times 0.25 squared, don't forget your square, plus 8 times 0.25, close the parentheses, plus 9, and then we get 10. So the maximum height of the ball is 10 feet. The maximum height. Any questions, comments about the work that I did there? Any at all? Okay. So if you guys are cool with that, maximum height is 10 feet. How long will it take the ball to reach its maximum height? Well, we already found that. That was the h value. And it says round to 2 decimal places, which we got 0.25. 0.25 seconds. Boom. Got both those pieces. Okay. So I said I wanted to get out of here early. So I'm gonna leave it there. But guys, I don't want you guys to think that you can't continue getting help. Remember, I give you a window of about 3 days to try to get that test in. Okay, so you have until Friday. Tomorrow we're going to be starting on new material. So if you still need assistance, go to Math World tomorrow. If you have some time before class, pop into the Zoom session with them and ask them like, hey, I'm having trouble with this problem on the review. Can we go through it? Or if you're still struggling with, a problem from the worksheet, like say, hey, can I work on this problem from the worksheet? And then they'll be able to help you through it, right? Because they're all instructors. They all know me personally, and I'm in there talking to them every single day. So if you guys need help, ask for that help. Because like as we talked about at the beginning of class, as Ian pointed out, it seems impossible that we're going to get through at the end of these next 2 weeks another test, and then at the end of the next 2 weeks another test. But like that is how fast these summer classes are paced. Okay, so there's no time to delay. I've been saying it, but hopefully you guys realize now it's coming in fast. You need to make it a priority to get help. Please heed my cry. Ask for help when you need it, and not after the time is already like sort of run up on you. So just get some help. Ask for that help from the tutors, and send me a message if you need some additional assistance. But tomorrow we're moving on to some new material, so that's the last I will talk about test number 2. Okay. So if you need to go, get out of here. I do want to get you guys out of here a little bit early today, but if you want to hang back and chat for a few minutes, I will stay on for the next 5 to 10.